2C, more graphs for quantitative data. So we've dealt with frequency histograms, relative frequency histograms, frequency polygons, cumulative frequency plots, otherwise known as ogives, right? We've dealt with those, but there are other ways that we can represent quantitative data. So we're going to go over a few more of those. The first one we're going to deal with is a stem and leaf plot. A stem and leaf plot. Now, when I deal with these, I kind of like to draw myself a little picture here. So we see why I'm a math teacher, not an artist. But you gotta admit, that's not as horrendous as it could have been. At least it's not a flower stick picture. That would be interesting. Okay, so the reason I draw this is not just to be funny about it, but a stem and leaf plot. We've got a stem and we've got these leaves. Now, any given stem can have from 0 to an infinite number of leaves on it, depending on the size of the plant. So a stem can have no leaves, it can have one leaf, it can have multiple leaves. But any given leaf can only have one stem. The leaf grows out of the stem. It doesn't count if you got two plants that grew next to each other, and so the leaf grew out of the one stem and it kind of wrapped and it ended up growing around the other one. So stems can have 0 or a number of leaves. Leaves have to have a single stem. So that's why I bring this out. You see it's got a stem with 2 leaves. So just visualize that as we think about stem and leaf plots. So the idea of a stem and leaf plot is that you're going to create kind of a table, but it's going to give us a graph in the end where we have the stem and the leaves. Now, what do we mean by the stem and the leaves? Well, let's look at some data. 38, 56, 27, 31, 62, 58, 33, 24, 59. So here I've got some data. And I want to turn this data into a stem and leaf plot. And the idea is, with a stem and leaf plot, that we're going to break each of these data points into a stem and a leaf. So the way we do that is we create a key. And I say, and I have a tendency to look at the first data value when I create my key. I'm going to go 3 vertical line 8 is equal to 38. So what this is doing is it's telling this line is like this line right here. It's splitting the stem from the leaf, and it's saying that the leaf is going to be 1 digit. And the stem is going to be anything from the tens and higher. So here I have a stem of 3 and a leaf of 8. And that gives me 38. So now I can look at this data and I realize that I can break this into stems and leaves. Now, the smallest data values are in the 20s, the highest are in the 60s. So I'm going to have stems 2, 3, 4, 5, 6. I'm basically breaking them up into groupings of 10s, right? The 20s, the 30s, the 40s, the 50s, the 60s. Then I'm going to put the leaves on this side. Now when I create the leaves, I'm just going to look at a data value and say, okay, that's a stem of 3, a leaf of 8, and I put it over there. 56, 5, 6, 27, 31. Now when we get to another data value that has the same stem, we just put it right next, and we put its leaf right next to the other leaf. We don't put any commas, spaces, or other delimiters. We just put the leaves there. Because our key is going to tell us that we only look at one digit at a time. And once we get this done, I'll read that off and show you that. So we had 31, 62, 58, 33, 24, 59. So now we had 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. And I see 1, 2, 3, 4, 5, 6, 7, 8, 9 leaves. And notice now, because my key tells me that there's one leaf, the leaf is the ones place, and the stem is the tens and higher, I can read this as 27, 24, 38, 31, 33, nothing in the 40s, 56, 58, 59, 62. So I can read all of my data values directly off of this. Now, you may look at this and go, well, why do we need this key? Can't we just assume that it's always one digit for the leaf? And the answer is no, we can't assume that. Now I'm going to throw in some additional leaves here just to illustrate this point. 5, 2, 1. And I'm going to write a different key for this. So I have a key of 3 vertical line 81 is equal to 381. Now what this key is telling me is that the leaf is going to consist of 2 digits, the tens in ones place, and the stem is going to be the hundreds place and higher. So using this key, we have 274, 381, 335, nothing in the 400s, 568, 592, 621. So you can see that the key determines how we read it. In fact, I could go for another one here and say, what if we have this key? So now 3 vertical line 8 is equal to 3,800,000 or 3.8 million. So now, looking at that, I have 2.7 million, 2.4 million, 3.8 million, 3.1 million, 3.3 million, 3.5 million. So the key determines how we read this. So whenever we create a stem and leaf plot, we have to make sure that we create a key to go with it. Because without that, we don't know how to read it. It's kind of like having a map to help you get somewhere, and you don't have the legend that tells you 1 inch is equal to 2 miles, or 1 inch is equal to 50 miles. You're going to have a really hard time, especially if that 1 inch is equal to 50 feet, as opposed to a mile. You think that you're going to be driving for a while, and it was just the next turn. So the key is very important, and the key, if you leave out the key, you're automatically losing a point. Okay? Anytime you do it. And the key consists of not just this vertical line, but the definition of what it's doing. So 3 vertical line 8 is equal to 38. If you just tell me 3 vertical line 8, well, that's like saying an inch. But what's it equal to in distance for the map? So that's our stem and leaf plot. Let's put some additional information with this. So notice that we started in the 20s, ended in the 60s, and we had nothing in the 40s. Even though we have nothing in the 40s, we still need to leave that spot there. We can't just get rid of it and go 2, 3, 5, 6. Because if you look at this, I'm going to draw something in orange to kind of give us a visual here that you would not really draw as part of it. But what if I were to put these little boxes around these and tilt this, rotate it 90 degrees. And what do we have? Doesn't that look like a histogram? In fact, that's a histogram with a class width of 10, the 20s, the 30s, the 40s, the 50s. So really what we're doing with a stem and leaf plot is we're actually making a histogram with a frequency with a class width of 10 or 100 or whatever we happen to have from our key, and doing it without doing any real calculations. No real work. You think about it took to create a frequency histogram. Well, we had to find the class boundaries, or we had to find the midpoints, and then we had to count up how many numbers there were in each one, so the frequencies, and then we had to plot this whole thing. Whereas right here, we're able to do this just by writing in the numbers, and it automatically creates this frequency histogram. So it's a pretty neat thing here. Another thing to take note of is that sometimes we have a number such as 5. Well, if we have the number 5, how would we do that here? Well, isn't 5 the same thing as 0.5? It is. It means we have a 0 in the tens place. So if we're dealing with a single digit number, then we're just going to start higher and have 0, 1, 2, 3, 4, 5, 6. And now I have 5. Nothing in the tens. 27, 24, 38. So we can start in single digits, or even going beyond that, we could have 107, which would mean that we now have 7, 8, 9, 10, 7, 107. So we can go beyond those ranges without any difficulty. Couple more things to point out about a stem and leaf plot. One is that some people like to do things in order. Remember the Pareto chart. The Pareto chart was just a bar graph, but you started from the largest value and went to the smallest value. Well, we sometimes do an ordered stem and leaf plot, which means that we want our leaves to be in order. So instead of being 7, 4, we put 4, 7. Instead of 8, 1, 3, we go 1, 3, 8. This one's already 6, 8, 9. That was 2. So if you have an ordered stem and leaf plot, if you were to just start reading the numbers off, you would read them all in numerical order. 24, 27, because they'd already be in that order. That's an ordered stem and leaf plot. The other modification that we may do to a stem and leaf plot is we may do a back-to-back stem and leaf plot. With a back-to-back stem and leaf plot, you share the stems, and then you have leaves over here for one set of data, and leaves over here for another set of data. So now I have 20, 21, 36, 42, 41, 45, nothing in the 50s, 62, 65. So that way I can show two different sets of data on this back-to-back stem and leaf plot. So there's a stem and leaf plot. The next type of graph that we can do for quantitative data, and this is probably one of the more complicated graphs that you're ever going to have to deal with, so brace yourself. This is called a dot plot. A dot plot, which means we're going to plot dots. Okay? So let's get some data here. Let's say we have 56, 61, 56, 60, 75, 63, 61, 63, 56, 72, 61. Right, so we've got a number of data points here. So 50, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. And we're going to create a dot plot. Now with a dot plot, we're basically just going to create a number line that will cover all these data points. So I've got 56, looks like my lowest one, 75 is the highest, so I need from 56 to 75. So I'm just going to do a line here. I'm going to go 50, 55, 60, 65, 70, 75, 80. So that should easily cover from 56 through 75. So we got that there. Now with a dot plot, we literally just plot a dot for each data value. Which means that I look here, I got 56, and I go, okay, 55, 56, and I put a dot. 61, and I put a dot. 56, well that's a second one there, so I'm going to put another dot right above the first one. 75, that's a dot. 63, dot. 61, well that's my second 61, so I'm going to put one above it. 63, there's another 63, I'm going to put a dot above it. 56, yet another 56, so a dot above it. 72, plot a dot. 61, another dot. So now we see that we have a dot plot. You put a dot for each of the data points, and if you've already got one for that data value, then you put it above it. And you can see that this is essentially creating another frequency histogram. It's just doing the counts for you, and as you put more and more data in there, you get more and more dots, and you see the shape of it. This is just a frequency histogram that each class is its own number. So each class has a width of 1. And so it's really easy to plot. What you have to be careful of with this are two things. One, you have to make sure that if you have a repeated number, you recognize you already did it and you put them on top of each other rather than accidentally putting it beside. The second thing is people have a tendency, well, some people like to put hash marks. They like to put a little mark at each of these to make it easier to plot it. Now, when they do that, they have a tendency to want to put their dot higher because that hash mark is there. And now that's a problem because that makes this the same height as the ones they had too. So if you are going to put hash marks, make sure you do so in such a way that your plotting is consistent. Your first data value always shows up at the same height. Whether that's you start them all up a little higher, or you do your hash mark just the bottom half of the hash mark, or whatever the case may be. So that is a dot plot. So maybe it wasn't the hardest graph you'll ever come across. The final type of graph that I want to talk about here for quantitative data is a time series plot. So it's a time series plot. So basically we're going to be dealing with X and Y values, but what we're doing is with a time series plot, we are taking data at set time intervals. So every hour we check something, or every minute, or every 10 minutes, or whatever the case may be, each day, right? So it's a series of times where we take data. So what I'm going to do here is I'm going to create some data for us. So in a face-to-face class, I looked at the time in the class and the number of students sleeping. So at the beginning of the class, there was 1 student sleeping. 5 minutes in, 3 students were sleeping. At 10 minutes, 6 students were sleeping. At 15 minutes, 11 students were sleeping. at 20 minutes, I got a little fed up at 18 minutes and I slammed a book on the ground. One student was sleeping. At 25 minutes, 8 students were sleeping. So now I took a series of times, 5-minute break in between each, so consistent time frame, 0, 5, 10, 15, 20, 25, and then I looked at how many people were sleeping at each of those times, creating my time series plot. So to graph this, I'm going to plot the time on my x-axis and the number sleeping on the y-axis. We call this first column, and for me it's always the first column, but we call this the independent variable, meaning that it's based on nothing but itself. I took readings at certain times, so it was 0, 5, 10, 15. Nothing caused that. That was its own thing. Yet the number sleeping, that's called the dependent variable, because the number of people sleeping was dependent on the time. At that particular time, that many people were sleeping. So x would be the independent variable, y would be the dependent variable, and I always draw my tables of data with the independent variable first and then the dependent variable second. The independent variable, this x value, is going to go on our horizontal axis or our x-axis. So we're going to put those on here. 0, 5, 10, 15, 20, 25. And then the number of students sleeping, and remember we always label our y-axis, so number sleeping, is going to go on the y-axis, and we've got up to 11. So I'm just going to number to make sure that works. Consistent indices, 2, 4, 6, 8, 10, 12. Right? So now I have my y-axis labeled, and I'm just going to plot each of these points as a dot. At a time of 0, 1 student was sleeping. At 5 minutes, 3 people were sleeping. 10 minutes, 6 people. 15 minutes, 11 people. 20 minutes, back to 1 person. And at 25 minutes, 8 people. So now we've got a bunch of dots here, and since this is a series of data points running from time to time to time, we're going to connect those dots. And we're going to connect them with line segments. So straight lines. Or as straight as we can get with our drawing tools that we're using. So this is a time series plot. Do not connect these down to the x-axis unless that's actually what the data value was. And use straight lines. Now you may say, but Mr. Davis, I've had instructors tell me in the past that when I plot things like that, I should use a curved line. And some teachers get so finicky that they want you to use a French curve, which allows you to get the curves nicely. I used to have this flexible curve thing for making these curves. The reason I'm telling you to use a straight line is because there's a difference between a straight line and a curved line when you're drawing a graph like this. A curved line implies a flow, that it's flowing along through. With a curved line, if I were to go between the 5 and the 10 and go halfway, then I could assume that that halfway point would be approximately where that graph is located. But that is not necessarily the case. This is disjoint. We took data at certain data points, certain times, but we don't know what happened in between. Sure, I slammed a book somewhere at 18 minutes, which caused people to wake up, and so I had only one person asleep at 20 minutes. But for all we know, in between 10 and 15, we may have it went from 6 to 11, but it may have gone down to nobody and then up to 11, or it may have gone up to 20 and back down to 11. So the straight lines tell us that this is a series of data values. We followed set time intervals, but that this should not be used to approximate how many people were sleeping in between those times, because we don't know. It really wasn't a consistent or continuous flow. So that's a time series plot. Always put the dependent variable on the y-axis, the second column, number of people sleeping, the independent variable on the x-axis. Draw the dots, then then draw the lines in between them, and only come down to the x-axis if the data really does that. Notice also, I've got a 0 here, and I didn't put it right at this y-axis here. And that's fine. You can start wherever you want. I could have started at 40 minutes into the class and just started with a 40 or whatever, and that doesn't matter. I also may have run into a thing where I never had below 20 students asleep, so maybe I started at 20 and went up to 30, so I didn't number this directly. That doesn't matter as long as we're consistent on our indices once we start numbering. So there we are for more graphs for quantitative data.